In this lesson, I'm going to introduce you to a tricky little concept known as nested loops. A nested loop simply means one loop inside of another loop. And that is what we have here in the example before us. On line 1, we begin a loop that is to happen 2 times. Ruby will proceed with line 2 and print the string outer to the terminal. It will then encounter line 4, where it begins another loop. Now, this second loop is actually taking place within the first loop. How do I know that? Because it's taking place before we've encountered the end statement for the first loop. The end statement for the first loop is on line 8. Ruby has not encountered that yet. So while still within this first loop, Ruby is now beginning a second loop. I will call the second loop the inner loop and the first loop the outer loop, because the inner loop is within the outer loop. Now, people often get tripped up with understanding how the code flow works when dealing with nested loops. So let me give you a simple rule of thumb, and that is that an inner loop always gets run through to completion right away before Ruby moves on. Let me show you what I mean by applying Peter Jang notation to this code here. So let's take it from the top. Ruby will first encounter line 1, and then line 2. We're going to skip line 3 simply because it's blank. Ruby then encounters the inner loop that begins on line 4. So that is the third line of code that Ruby runs. Now, Ruby is going to run this inner loop through to completion as follows. It's going to print inner to the terminal 1 time. Then it encounters the end keyword for this inner loop, which bumps Ruby back up to the beginning of which loop? To the inner loop. So it will run 6, 7, 8, 9, 10, 11, and then Ruby will run this inner loop a 4th time, as it's supposed to do because it's a 4 times loop. Once Ruby has run this inner loop, it will move on and encounter the end keyword on line 8. So that is the 15th line of code that Ruby runs. Now that Ruby has hit the bottom, but only has run the outer loop once, and it needs to run it a 2nd time, this end keyword on line 8 bumps Ruby back up to the beginning of the outer loop on line 1. So line 1 becomes the 16th line of code that gets run. Ruby then runs line 2 as its 17th line, and then encounters the inner loop once again, and will run it 4 times to completion before moving on. So that was the rule of thumb, that the inner loop always gets run to completion before moving on. And then finally, Ruby will hit the end keyword on line 8, and that is the 30th line of code and the final line of code that Ruby runs. So now that we've applied this notation here, can you predict what will happen when we run this code? Well, you could. Following Peter Jang notation, we can predict exactly what will happen. So let's just focus on the order in which the puts statements occur. So the first puts statement to occur in our notation is 2. So outer should print to the terminal. And then inner should get printed 4, 7, 10, 13. Then outer should get printed again as part of 17. And then inner will get printed 19, 22, 25, 28. So we should get outer, inner, 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 outer, inner, 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 inner. So let's run our code once and for all, and we will indeed see that is what we get. Now, if you want to apply the technique of unwinding a loop to visualize this in another way, I always recommend unwinding the outer loop first. Let me show you. First, we'll get rid of our Peter Jang notation. And let's make room for the code. And now let's unwind the outer loop. Remember, to unwind the loop, we take all the code within the loop and copy it, and then paste it for as many times as the loop is to run. So now we can follow this code top down. What's going to happen is the computer is going to first print outer, then run this loop 4 times printing inner. Then it's going to print outer again, and then it's going to print inner again 4 times. So by unwinding the loop, that's another great way of visualizing this loop. Of course, we can then go ahead and unwind the inner loop as well if you find that to be necessary. Just for the sake of completeness, I will go ahead and do that. So this is the loops completely unwound. Again, the trick here is to first unwind an outer loop and only then unwind the inner loop. In future videos, we'll actually show you why you may ever want to write a loop inside of a loop, but for now, we're going to focus on just being able to read it and figure out what happens when confronted with one.